I'm going to click save. And so now we are recording. Can everyone hear me?
Yes.
Okay, good. All right, good to hear. I've got the, you guys know everyone knows my setup right here. Okay, so a couple things I'm going to talk about. Today we're going to talk about the idea of change detection analysis. It's a big fancy way of just saying what happened before, what happened now, how do we map the change? And we're going to look at a couple examples where the change can both be quantitative and qualitative. Now, when I use the words quantitative and qualitative, what's quantitative imply? Numbers. How about qualitative? Not numbers, descriptions, or whatever. So we're going to talk about a project that one of our master's students did where we looked at change detection analysis between crime rates in 2019 versus 2020. Now, one of the big challenges that I also think of or look at, and some of the things that I've seen here recently, that a lot of people just want, what do I click on to get the answer? What do I click on? Tell me what to click on. We're going to look at a couple of these jobs here. Are you interested in any of these? Some of them, yeah. So, a lot of times he was like, tell me what to click on so I get the answer. Like, what's the answer? Like, and what is really more important? You get the answer. You know what I mean? And a lot of times, some of these maps and these projects that we put together, it might take 3 or 4 days just to get the data. Let's work on getting the data, because a lot of times when we looked at that NC, the vital statistics database, those columns had different names throughout the years, like death state versus D state and all these other things. So you gotta line those things up. So you got to figure out all the technology so those things can be brought into GIS, because we're looking at like a couple million records. Okay, next we got to run those summarize. You got to remember what that summarized. All right, let's count the number of times something appears. And all the GIS techniques that we're talking about here were all things that we covered in the first 3 or 4 weeks of our kind of intro level GIS stuff. So for some people, we're kind of scratching the brain. Other people are like, oh, this stuff is easy. And so those of you doing it, learning it for the first time, it's a matter, getting it good here. And we're going to do a GIS tutorial. We're going to look at time series analysis, because I'm not good at time series analysis, but ArcGIS Pro has some really neat tools so that you can make movies and all this other stuff throughout time. A couple things that we're looking at here as well. Let me just see who we got here. We got Caitlin, Lauren, Kaya, Tamar, Chantel. Good. Okay, cool. All right, good to have everyone here. And so the biggest challenge we have is just making sure you're being understanding of software and what to do with the data. Excel, I think, is pretty straightforward. But when we look at the midterm exam, which we're taking in actually 2 weeks, we're going to go through the exam. They're going to simulate everything that we did in the exercises. So it'll be exactly from the exercises, but instead of top 2013, I might call it median age. And I'm going to put everything into ArcGIS Pro, and I'm going to put everything into Excel. So you'll have Excel so that you can go back and forth between the two if you want to use Excel, if you want to do histograms, if you do whatever you want to do with these. So I'm kind of excited about the way that the exam is going, because I was talking to Zanaya a little bit, and she was talking about, well, there's a lot of different ways you can kind of answer the same problem. That's kind of what you were talking about, right? I don't want to take you out of context. So we can get the mean from different things. Yeah.
2 weeks.
2 weeks, yes. Week 6, right? I'm not asking. I think I'm.
Time flies.
Yes, time is flying. We're in week 4 right now. If this class works out, we usually end like a week early. So, so we'll end like second week of November sort of thing, because I might be going to California and. Yeah. For graduation, yes. I sent that stuff out to all the advisors in the DEGS this morning. So your advisor should be reaching out to you. Or I spoke to Dr. McGinn today. He's going to be working on all graduation applications for undergraduates. So grad students are a different story, which I'll be working with as well. So this, some of the things that we're doing with GIS is just one of kind of the tools that we're going to be utilizing, because we're going to be looking at real life GIS data in this class and mapping change, COVID change and COVID rates between two different dates, because obviously the change from one date to another will be different than the change from another date to another, especially over the period of like a 3-year pandemic. One thing I always like to look at is a place called USA Jobs. USA Jobs, I just type in the word geospatial and statistics and look what pops up. $105,000 a year, $64,000, $70,000. I thought I saw another real nice one. $86,000, $112,000, $104,000. We have a cartographer right here, $136,000 a year here. And so this is from USA Jobs. These are going to be government jobs largely. You can also go to a site called governmentjobs.gov or something like that, and those will have like local, state jobs and municipality jobs, but these are typically working for the federal government. And I thought these were kind of neat here, where you're doing advanced analytics. This one was something up here, technical targeting analyst. I thought this was neat. From $64,000 up to $172,000 a year, and you are using like GIS and statistics, econometrics, geospatial modeling, mathematics analysis, network security, and engineering to basically like figure out what targets, like soft targets, hard targets, all that other stuff for the U.S. government. I thought this would be pretty neat, pretty neat job here, and it has the job up here. Targeting technical analysis evaluates technical and scientific data to provide insights that unite technical operations and technical development activities to maximize intelligence collection strategies. Yeah, and the big thing with these is the most important thing is the quality of the data. If anyone's heard the term GIGO, garbage in, garbage out. So when you look at all these projects and these readings and all this other stuff that I assign you, like the biggest thing is you got all this data and you got to figure out what you can do with it to turn it into something neat, something pretty. Because you already looked at my paper on urban, rural, food security, all that other good stuff. What was your final synopsis on it? What's the right answer? I know we were so focused on getting the right answer, but what's the right answer? What was your overall kind of take from it? Rural food security is a problem in North Carolina, right? It's more pressing in rural areas than suburban areas as well as urban areas. It's just less people are impacted, but there's a lot more people that are food insecure, meaning they have low access and high poverty rates in rural areas, which was much, much higher than these other areas as well. And so I thought that was pretty neat, just using data that's out there that's able to be collected. But I saw some of these jobs where I typed in the word geospatial, geostatistical analysis, and all these things with like intelligence come up. Processing specialized software techniques, whatever MTI is. I don't know what MTI is. But theater geospatial intelligence analyst. This stuff looks pretty neat, really neat. A 2-year trial probationary period may be required. Get top secret clearance. Wow, look at all this stuff. A lot of things here. Veterans preferences or whatever. So if we have people who are veterans in here, what does veterans preference mean? You're a veteran, you get like points added to your score just for you being a veteran. Irregardless of skills, education, or any other ways that they assess and evaluate your application. I thought this was pretty neat. This was really neat here. These are just some applications here that marry the geospatial analysis, the geostatistics, and so this geostatistics that we're doing is just going to be a tool that you can use to do these jobs. There's not GIS technician jobs out there that pay $104,000 a year. No, they're just not. They start at $40,000 or $45,000 or $50,000 and work your way up there. So if you're a technician your whole life, you're not going to be making $104,000. You're going to be applying for a GIS analyst job, and a GIS manager job and a GIS coordinator job that do pay things like this. Or, if you want to be happy being a GIS technician, that's, certainly fine as well. So today, I talked about some of the preparation that we looked at. I'm going to give my spiel and my shtick in the first part, and then we're going to open up something called case study number 2, where we're just going to calculate the differences between 2 different columns. It's called change detection analysis. We're going to look at all the different applications and ways that change detection can be manifested, expressed, and I'll show you some examples that I did, as well as one that one of our former students, a master's student, he was an undergrad student in criminal justice, also did. Also, I've updated a number of different videos here. So I'm in the process of updating some videos, but I did put 4 new videos right here. I've got to do a couple other ones here with that utilize some of the old software here. But I talk about migrating between ArcGIS Pro and Excel. So how do we go between ArcGIS Pro and Excel? I see some cool stuff in Excel and I want to stick it, or I see some cool stuff in ArcGIS Pro and I want to stick it into Excel. I don't have to export anything to CSV files. I can copy it and paste it right into Excel. And I think everyone in this room and everyone doing this virtually should have the skills to open something up, select something by attributes, copy that thing to Excel, and do the mean, median, mode, descriptive statistics. Because if you looked at some of those job descriptions, they had things like descriptive statistics, regression, all these other things that we're going to talk about as well. I also talked about measures of dispersion. So I go through, I give you a data set of, I go through and do a data set of standard deviation. I calculate standard deviation, variance. I think I calculate z-scores. So I do a whole video where I calculate these because you might need to do that at some point in time in the future. So pay attention to these. And when you take the exam, you're more than welcome to use the videos because you're not going to have the exact same data set for the videos as you do on the exam. I also put in a data set there where I had 2 different data sets that had the same exact mean, but different standard deviations. I have measures of central tendency, mean, weighted mean, median, mode. So we went through and calculated for a data set, I think it was income in North Dakota, income in North Carolina. We calculated the mean, weighted mean. What's the difference between the weight mean and the weighted mean? The weighted mean Maine, no pun intended. I calculated the average, the median household income for all counties, all 100 counties in North Carolina. Which one weighs more? If I were just to average them up. None of them do. Wake County has a much higher population that would contribute more to the income than low population counties like Hyde or Tyrell County. So when we do a weighted mean, we do that. And within this video, I actually go through and calculate your GPA. I went through, did a little GPA calculation because you just average up A, B, B, C. You base it based on what? The credits you're taking. So the 4 credit class is going to count more than the 1 credit class. So I do an example there of weighted mean. And so if you see a quiz or an exam and I provide you with the data for the exam in Excel, you should be able to calculate the mean, median, standard deviation, z-scores, all that other stuff within the confines of Excel, as well as we can hand calculate those. So we kind of do those the hard way as well. So we got measures of central tendency, dispersion, and then I also created another one here, the need for normalizing data. So what we looked at was hailstorms in North Carolina. There was like 9,000 of those. And then I normalized those by the area of each county because I did a little bit of density mapping here. I put some new videos up there just because I'm utilizing the new ArcGIS Pro software, which is a little bit newer. There'll be some other things here, mapping change that I got rid of here, but we're going to be focusing on change detection. This is mapping change. This is actually using the homework data, but just using the old software. Looks and feels the same way, but today we're going to be focused on change detection as well. So I'll talk about a couple of things here, and then we're going to just kind of get hands-on with this stuff here and kind of get familiar. We're going to revisit the exercise that we looked at last week, where we're going to be looking at heart disease deaths, cancer deaths, in southeastern North Carolina using that summarize button. So this summarizes kind of what we've been talking about. Select by location, coins, summarize. These are all kind of tabular operations we talked about in the first half of our intro GIS class. They're largely covered in the GIS basics. So we're just going to kind of go through and reiterate these. Because at the end of the day, what are we doing? We're not doing this fancy analysis. We're preparing data so that we can bring it into Excel. We got lots of data out there sitting there so we can run cluster analysis and all that other good stuff. Because if I were to run cluster analysis on depths, well, that's not going to be very useful because those data need to be normalized. And we talked about the idea of age grading last week as well. So we've got some really kind of important things that we need to do or look at or whatever here. So today we're going to look at a change detection analysis. What happened before, what happened after. And so I'll show you a couple of the things that I've done. I'll show you some of the stuff that William, one of our former students, has done. And I'll kind of just go through and focus on some of the crime analysis that he did for different approaches. Because at the end of the day, in ArcGIS Pro, if you've got a column, can you calculate it from other columns? Yes. We have a column, make a new column, calculate new columns. Did we do that last week? Yeah. What did we do? We normalized data. We looked at, I forget what it was, the death rates or something like that, right? So we just counted the number of deaths by zip code. We know that higher death zip codes might have more people, so we just normalized by population. So we looked at the number of deaths per 10,000 people. So we had this checkerboard map that turned into a map where there were a lot more deaths down in the southern part of that, Sampson County or Clinton County or whatever county towards the south of that, as opposed to up near Fayetteville. So what are scenarios we want to look at change? Because at the end of the day, we want to, how are things changing over time? How and where have COVID rates changed over the course of the pandemic? Is the pandemic still going on? I don't know. High school graduation rates change over time. How have patterns of crime changed since the city annexed land? Or where have Dollar General stores been added within a study area? Oh, cool. Yes, they put a DG Market, Dollar General, right? Yeah. Oh, cool. Like right around the corner from me, they put a market. So like if I wanted to, I could go buy bananas or apples or bread or whatever. I like it because it's cheaper because across the street is a Lowe's, which is really expensive. So I always go to the discount stuff in the back. Do they have discount racks at your Lowe's? I just go back there and get the discount stuff. But I go to the Dollar General as well. So one of the things that I did for economic geography was that I was looking at variety stores like Dollar General, Dollar Tree, Family Dollar, which are good sources of basically cheap food. In some cases, they've got the markets where you can go and get milk and other perishables. In other instances, they don't. But this is a map here of Caswell, Alamance, Guilford, Rockingham County. We've got Durham County, Orange County, and Durham kind of sitting right here. And so we can see the dots here that are dollar stores that existed in 2009. And then we've got dollar stores that existed in 2007. So just something like this is an example of change detection. So we can look at where new stores were added. Pretty straightforward. So when we talk about change detection analysis, CDA, it might not be all that fancy except looking at something like this. Now in remote sensing, have you talked about change detection analysis in remote sensing yet? No. Basically, I have an image from 2010. I got an image from 2020. We stick them on top of each other, and how do they look different? Now we can do that quantitatively or qualitatively. We can do a little slider thing that slides back and forth so we can see what was there before and after. We can look at reflectance values and greens and all those other things. So there's a lot of things that we can do with those. But at its most core level, this is change detection. What's different? That's all it is. Now, how do we express that within a GIS here? This is what's different. So I had the old data, had the new data. I just found out the new stuff that didn't coincide with the old stuff. And we go. And some of the strategies of especially like Dollar Generals, and this is one over near me, over near Brown Summit, and they just built another one like right about 5 miles away where I live, but they put up a new Dollar General right there. If anyone goes to Nextdoor, which is kind of like Nextdoor, has anyone heard of Nextdoor? Kind of like this app for like what's going on in your neighborhood. People go and love to complain about the Dollar General, but it's always kind of full, so but you can see they've really tried to target rural areas. And like you were saying, you only have to go 10 minutes to Dollar General instead of going 30 minutes. And so that the time savings. So these are places that kind of highlight those. So this is an example of here we've got COVID-19 rates. Now, some of the things, this is as of 4/17/2021. Okay. It's going to change on 5/17 and 6/17 and 7/17 and 8/17. It's going to change. So how do we look at these? Now, one of the ways we can do this is using cluster analysis. We've all heard the word cluster before, right? Cluster. We're going to talk about this at the end of class, but all I did was, can you all make a map that looks like this of COVID-19 rates? Yes, Alondra's nodding her head because yes, we can. Because all we need to do is we got the number of COVID deaths. We normalize by population. This is all stuff that we did last week. And then we literally click a button or two and turn it into a map that looks like this. So that now we can look at hot spots and cold spots. Hot spots and cold spots are just areas that are inordinately high above the mean compared to other values above the mean. We talked about what the mean means. I mean, we just average them all up, the average. So we got some, these things are going to be building upon each other. So these areas in red are really high values surrounded by other high values. High means a lot higher than the mean. What do you think the blue represents? Low values. Now, what does low mean? Well below the mean, surrounded by well below the mean. And so it doesn't elicit or bring out what we call spatial outliers. Has anyone heard that term before? Spatial outliers are high values surrounded by low values or low values surrounded by high values. Because in theory, the highs are near the highs, the lows are near the lows. And then this does it with what we call statistical significance. So we can see these as of 4/17/2021. We'd see these as 4 months earlier. So now, not many hot spots here in April of 2021, but a lot more here in a few months earlier. This is Sampson County right down here, right? And you can start to see your hot spots are really moving over here. So this is another example of change detection analysis. And what I might do is make a really nice, pretty map that kind of shows, hey, we're going from no cluster to hot spots to cold spots, and do something like this. So I can make some nice, pretty maps like this. But when we talk about attributes that need to be normalized, we look at population change by county. And so non-normalized, if I were to say, Wake County gained 1,000 people last year, is that a lot or a little? Little. Right? They probably get 1,000 people every week, right? It's a little. Why? Because they got a population of over 1 million. Now, Tyrell County or Hyde County, which has a population of 5,000 people, is that a lot or a little? It's a lot. No, that's a lot. So the non-normalized version of this is population changed by county, which in this case can be positive or negative, where that percent population change. Now, remember how you calculate percent change? Remember this from math class way back in the day? Let's make it new minus old divided by old and multiply the whole thing times 100. And so we can do this in Excel because we've done this in Excel, right? We've got one column, we've got another column. Hey, let me calculate a z-score. Let me calculate those quality points. So I think everyone in this class can go back and forth between Excel, whether you're a history major, psychology major, environmental science major, whatever your interest is, at the end of the day, we're going to want to look at data sitting here in Excel that's been calculated at some level. And after the break, I might show a couple of examples where we're looking at data that articulate and have a need for change detection analysis. So we can look at something like this, where we have change detection analysis, where we look at the difference in high school graduation rates between 2007 in 2012. Now, why is this even? And we can see this county up here. I'm not sure. Is this Watauga County or Ashe County, where the population, where the graduation rates went down, and you can see where they went down here. But even this might be a little bit kind of jaded. We have to take with a grain of salt. Where we see some of these counties here, like Kern County, didn't go up that much. But what's the highest graduation rate you can possibly have? So if a county is 97%, it can only go up 3%. Where that some of these other counties here that are plus 14, what does that tell you? Well, they go up. They had a lot of room to improve. And so there's lots of reasons for this, and I think some of these have to do with the idea that they were calculating 4-year graduation rates versus 5-year graduation rates. Even the COVID rates have to be taken with a grain of salt, because at one point in time they were only taking like single cases. So if I got COVID 3 times, then I only counted as one case. And so the highest rate you could have is 10,000 rates for every 10,000 people, one case for every person. But they changed it later so that if you kept getting COVID, you could have 20,000 cases for every 10,000 people, which basically meant every person on average got it twice. And so they changed those halfway through based on whatever reporting standards they have. So we need to take those with a grain of salt, just like we need to take this with a grain of salt. Now we can manage these in Excel. We can manage these in ArcGIS. And so we've got a column right here where I have top 2004, top 2000. And I can just calculate the population change. Remember, when I put that little equal to sign there in Excel, we need to go start putting in formulas. Now, I could type in the word average. Average means it's some sort of keyword, and I can highlight all the data that I'm averaging, or standard deviation, or variance, or I can calculate the z-score, and we did this already. I've got a video on this where I calculate the z-score, which is what? Z equals the actual value for the county minus the average divided by the standard deviation. And so you can hand calculate those if you want, or we can just throw these into Excel. So you have the opportunity to do both of these right here. But now, this average right here is just going to be 100 times L2 minus K2. So new minus old divided by old times 100. Can you have negative values in population change? You have zero values. Of zero population change. Give me a scenario where you would have zero population change. Those of you join us online, you can kind of zero population change. Exactly. If L and K are the same thing, then guess what? They haven't gone up, they haven't gone down. You have numbers over 100. For percent population change. Can you have numbers under 100, less than negative 100? It would be hard, but I could have 300% population change. That means it would like quadruple or something like that. But if this was 1,500 and this was 30, we're going to have, no, that doesn't happen very much. If you've taken Dr. McGinn's class, when you look at population change by counties, we're looking at like over 1 year period, like 1 or 2% is really, really high. And so based on immigration, everything else. So now when we calculate this column, remember, I type it in, grab the little corner here, and I just drag it down, and it calculates for everything, single thing here. So now you can see that first line we had, which was slightly less, is negative 0.13%, 36%. So you can see this went up almost a third. 11, 8.08, 2.4. These are over 4 years. So when we look at population change, these are the rates that we're looking at. Here's another one here. Part of an impact evaluation for a problem analysis, you're asked to reduce commercial burglary. You're asked to prepare a map that compares before and after burglaries. So now we're looking at commercial maps here. This is over in Winston-Salem. So we've mapped these by block groups. Block groups are subdivisions of tracts. Tracts are subdivisions of counties. There's a lot going on within the county. So if I were to just map county level crime, it's going to be, there's lots of different crimes. So we can group them by census tracts, or if we got even better data, block groups. And we can calculate these by rates per 1,000 people because I know how many people live in this. I know how many people live here or here and here. I can look at correlative statistics where I know the average age of this. I know the average age of the home. I know the median household income for right here. Now you got to do a little work and digging, go through and get those data, and that's part of the data preparation process. Because in this class, where do you get most of the data from? Yeah, I spent all summer kind of just putting them together. Here it is. And work with it. Now we still got to do a little prep work here. We don't get right to the end, but I did a lot of the heavy lifting with some of these. So when you see some of these people want to do a lot of these research projects, a lot of the work goes into the data prep. This is the second map. One of the things that we can do is, why don't we just subtract it? So we can see these areas in blue, they went down. These areas in red, they went up. Well, that's easy enough to do. We've got another study area here. We can look at areas within a study area or outside of a study area. So now I can look at population, median age, percent minority, rental units, vacant units, median household income. And so we can start to look at Durham crime data where we can map these. If you have the address of something, can you make a map out of it? Can you stick it onto a map if you have the address of something? Has anyone ever done that in their life? It's called geocoding. Have you ever done that, Zanir?
No, actually, at work, we just type in like the address, and then it'll pull it up on.
We do this every day with these things, right? You type in a little address and boom, up pops a map. It pops up on a map. Now, have you done that 2,000 or 3,000 times? And we did that with your work, right? Yeah, with a couple of your projects, right? But you had all the addresses and we mapped those, right? It's geocode. I think it was like 600 or 700 points.
So it was 300 points.
Okay.
No, it was 300 valid points in the study area. I don't remember what the was, but we're looking at just Durham County, and it was 300 points in Durham.
All right. Benjamin's talking about a project. You joined us online where we mapped about 300 points. How long did it take you to do that?
It took us to find the geocoder.
As long as it took to find the geocoder, and it just did that, right? What do you mean by valid points?
So our study area was Durham County and points outside of Durham County. So they weren't part of the study area, so they were not valid points. They were deleted off.
Did you get any bad addresses?
No.
Okay.
No, I didn't.
Because once in a while you're going to get bad addresses, and we're going to look at these as well. And so when we look at these, this is the map of what this data looks like. Because if we go to the Open Durham website, you're going to just get a big list of every single crime that's happened, and you can filter it. We heard the word filter before. I think I mentioned it before in this class. Filter, I can just click on a column and just say, hey, give me 2017, 2018, 2019. Forget about everything else. But when we look at the GIS, it's got an address right here. It's got an X and a Y right here. Are these latitude and longitude? I see 2,003,213.75 versus 800,409. What coordinates are these? This is called State Plane, North Carolina State Plane, where there's some 0 point way down in Alabama. Now, everything in the state of North Carolina is in the first quadrant. What does first quadrant mean? Positive. Okay? For that, we work with geographic coordinates and longitudes and latitudes and angles. And, I don't want to deal with that. And so I'm just talking about all the data preparation stuff going on. These are kind of the big things that you think about here. And so we can look at spatial join. Does that ring a bell? Yeah, we could spatial join. Count these by block groups. Standardize. This is what we did 2 weeks ago. This is what we did last week. Location queries. These are all things that we know how to do. Now you got to put these together in the right order. Put them together in the right order here. Because like I said before, a big part of project management, and I think I'm probably a little bit remiss in doing that, is all the things you want to do to make this happen. A lot of times just what button do I click on to do this? And those are really powerful soft skills, thinking real big picture about, I want to do this over the course of a semester, and I'll probably talk a little bit more about that in a couple weeks when we talk about the actual project that we have that I'm going to be giving to graduate students, where you're going to do a position paper and you're going to make a statement and then you're going to have to prove or disprove it using the skills that we're learning in the class. So we can look at Durham crime statistics within study areas. We can look at Part 1 crimes. Part 1 crimes are crimes against people and property. Part 2 crimes are less violent crimes, even though things like DUI and all those drugs are Part 2 crimes. But we can look at analysis and source of Part 1 crimes and aggravated assaults and all these. And we can look at the different types of crimes here. But what we kind of looked at here was this idea of the bullseye. This was about 10 years ago, 10, 12 years ago, where they were kind of focusing on crime right along the downtown expressway, a little bit north of campus here. This was called the bullseye. Like, let's get all the crime out of here. And we went and calculated it. So this was the bullseye for this particular area. And you can see largely green, decreasing crime. We got increasing crime. But really, what happened to all the crime? The bullseye. This is the bullseye right here. Really, what happened to the crime? It moved. So cool. They did a good job on the bullseye. But what'd you do? These greens can turn into greens and everything else stay yellow. These are greens, great, but they just moved over literally to the other side of campus right there. And so those are some other things. City of Winston-Salem. I talked about this a little bit with annexation. They provide crime data. And like I've said before, if you go to Indeed, there's cities out there like Wilson, Reedsville, in Hickory, and relatively small counties that are looking for people to do their crime analysis. You would literally be like the crime analyst person, like, what are we collecting? How are we collecting it? Where are we getting it from? Like, to me, like, you are in charge. You are the boss of doing this stuff here. You're not working for anyone. You're not doing parcels. You're not doing any of these things. So a lot of these cities out there see the value in crime intelligence to hire people to go in and do a lot of this analysis, where we map crime in Winston-Salem. These are crimes per 10,000 population. We can map the change in crimes between 2000 and 2005. We can see that, well, the big problem here is that, look at 2005, 2007. The one big thing about Winston-Salem during this time period is that it gobbled up area here. We can look at area here. We can look up area right here. Can you see how this area down here was added? That didn't occur in 2005. So it went through an annexation. Has anyone heard that term annexation before? Annexation basically means, you might have heard of it from political science, but it just says Winston-Salem said, hey, this area down here, now you're officially part of Winston-Salem. You are in the city. Now, what does that mean? Does that mean anything special? What happens to people living here? What do they get in return for them getting to live in the city of Winston-Salem? City water, police, garbage, leaf pickup, or whatever. So why would people get mad about being annexed? Taxes, like, I don't want to say double, but probably went up like 50%. I used to live in the city of Greensboro, and my taxes were much higher. Now, compared to New Jersey, New York, Pennsylvania, they're nothing, but taxes go up. And especially out where I live, like, I take my wife or my daughter takes the garbage to work. I got a well. I don't need to worry. No big deal. Okay. So I hope that we don't get annexed. And actually, the city where the town where I'm in, they're talking about de-annexing an area, basically like giving it back to the county. Has anyone heard that one? That's funny. I never heard of that one before. But basically, the town voted against this big area not getting high-density housing because you have to live on like 3/4 of an acre to build a house. And someone came in and said, no, I don't want to do that. I want high-density housing so I can make a lot more money. And the town said no. And he said, well, I got a buddy in the Senate, So I'm going to try to de-annex and rid of y'all. Zoning issues. But it's like the golden rule. Those with the gold make the rules. So, so like 10% of our town might just go away and disappear. And logistically, it's in the middle of the town. So it's kind of, you form these enclaves and exclaves and things like that you hear about from like geography. Like some of the challenges of living in Alaska or Hawaii is that, I want to ship something up to Alaska. It's got to go on a boat or I have to drive it through Canada for a couple of days. But that's neither here nor there, where you can look at some of the changes here. And what we're going to talk about in a couple of weeks is some of these point pattern analysis where I can look at how crime has changed with descriptive statistics, because now I have something called the spatial mean. How do I calculate the mean of something? The mean of a bunch of numbers. Can you tell me in words how you would calculate the mean of something? Mean of all the my high school football wins. How would I calculate the mean? Calculate the mean of something. Because I threw these like sigma notations and x's and divide by n. But I just want to average up how many wins I had over the last 5 years. Add up all the years and divide by what? 5. So add them all up, divide by 5. Now we have something here called the spatial mean where I've got a bunch of latitudes and longitudes. What do you think the spatial mean is? Average up all the latitudes, average up all the longitudes, and bitty bop bitty boo, we got a single point right there. So once again, mean is a descriptive global statistic. What does this word global mean? Heard that word. Have you heard that word global before? It describes the entire data set as opposed to a local statistic that describes just one little record or one little enumeration. But we can look at the way these have moved a little bit. Another thing we're looking at here, and I'm kind of finishing up here in a little bit, and I'll show the example that one of our students did, which is really easy to read, really easy to go through, and he builds and he makes a really, really compelling case for change detection, COVID versus pre-COVID. Here, when I go through a QA/QC, what's QA/QC mean? Has anyone heard that term before? It's a fancy way of saying quality assurance, quality control, making sure the points are right. And a lot of times when you're a GIS technician, they might say, hey, you got to go out and GPS all the power lines in Wake County. Why? Well, we got to make sure they're correct. If you're out there GPSing those are correct. We got to make sure they got the right attributes and the telephone poles have the right condition and the right serial numbers and all those other things. Because if you're mapping a section of road and you accidentally type in the speed limit's 300 instead of 30, what's that going to do to travel times? It's really going to change those. Who's going to check all 800,000 sections of road to make sure all the attributes are correct? Not me. Some GIS tech like you all are going to do it at some point in time. I already did that a long time ago. Now, here we're looking at examples of the food environment here, where we have healthy food, unhealthy food here. Well, what would happen if we had a map here that we got from CAB data? CAB stands for Commercially Available Business Data, meaning CAB, they went and just gave us all this data. Here are all the supermarkets, but when I went out in the field, it really wasn't there. Like it had closed or whatever. And a lot of times when you pay big money for these databases, it's usually not right. Now, who's going to go out and check all of it to make sure it's right? You. That's why they invented graduate students or whatever. Now, we can do this a lot of different ways. We can use Google Earth. We can go out in the field or whatever. And especially if it's something that's local, that's really easy to do. And so we can look at before and after. Here are some supermarkets from before. Okay, you can see the total population here. And this is Orange, Chatham, Alamance, Yancey, or Caswell, and Person County here. So, you Person County or you Vance County? Vance County. So Vance is over here. And so we can see the total population, number of census tracts, block groups, total number of blocks here. And now, once again, we can see before and after. So we can see this point right here. This is down kind of where my parents live. But there's really no supermarkets right there. Even though when I got the database and you were doing like you were doing food desert analysis, we would say all these people are really there. But in reality, so what do we really care about? But when Diana said, "Oh, they're close," what was the main thing you said about your grandmother's house to the Dollar General? How close? 10 minutes. 10 minutes of what? Walking?
10 minutes of just driving.
10 minutes of driving. And so we can make drive time maps that look like this. This is what we care about. This is what I care about, right? When I type in something, I don't care how far it is. I don't care how long straight line distance it is, even though it's easier. I care about how long it takes me to drive somewhere. Now, have you ever typed in an address and it tells you how long it's going to take to get there? We do this all the time with these things. Now, has anyone made these maps before? Maybe, maybe not. So this is a drive time map that shows all the areas within 10 minutes of a grocery store. Now, this is before QA/QC, so you can see all these people, like my parents who live over here, where the commercially available business data says they're close, but they're really not. But now, after we QA/QC'd it, you can see what the 10-minute drive time really looks like. So before, after, before, and after. We look for areas of commission and omission. Commission means that we said it was a grocery store, but it's really not. We think omission means. Hey, there's really a grocery store right here, but it's not in the database. And those are a little bit harder to find. And so now we can make this map. And now we can look at before, after. So when we look at commercially available business data, you can see a general underestimation or overestimation. These commercially available business databases really overestimate the amount of food available people. Like they really don't encapsulate food deserts the way they should, because they've got like little convenience stores sitting out in the middle of nowhere that they say are grocery stores, but they're not on par with the Food Lions and the Lowe's and the Harris Teeters and everything else. So we can look at the differences between those. And we had a student work on this last semester where they said, hey, the business isn't a grocery store. It's not actually there. It's no longer open or anything like that. And so I'm going to show an example here of one of our students, what one of our students did, and then I'll take a break, because what we try to do here is think about how we can articulate change detection using GIS, using statistics, using all these other things. And what this student did, he was a criminal justice major. He was one of our non-traditional students here named William. He wanted to look at the statistical and geostatistical differences between pre-COVID-19 and COVID-era crime rates, where he picked April through June 2019 versus April through June 2020. So why didn't he just do, why did he pick April through June? Why didn't he do April through June versus June through August? Why did he pick the same 3-month period? See how similar they were. So we need to maintain consistency, because I would imagine crime, like any other phenomena, is going to go up and down throughout the year. So, why didn't you just do before, 3 months before COVID and 3 months after COVID? Because crime rates, dynamics of crime in January, February, March are going to be different than April, May, June. So those are the big questions that people think about in the background. Like, hey, did you normalize these? These crime rates are going to be different. So he did this. I don't want to talk too much about this. And he had a lit review of this. But the main thing we had is we went to the Open Durham GIS website. So if you go to Open Durham GIS, you can download GIS data for the city of Durham. Now, it comes up as a table. And so like Benjamin said before, I've got addresses right here. Then guess what I can do? I can turn this into a map here. Now, you notice these have these at the block level. No, actually the city block level. So it doesn't say 1103 or 5 Plummer Place. It just says 0, 500, 1700, 2300 or whatever. To maintain the anonymity of people there. You can see they happened in 2020 as a month. And what we did was just we went and mapped these using geocoding. Now you notice here I had to add the word Durham there. Can you add a column and then populate it? We did this last week. We added a new column, make everything the word Durham. Okay. What did we do last week? Made a little further. We made a little calculation that said this column divided by this column or whatever. But I can also just say, hey, make this column the word Durham, wherever it is. And so now I can type in 5300 Penrith Drive, Durham, North Carolina, differentiate it from the 5300 Penrith Drive and some other 5300 Penrith Drive but that might exist in the United States. And then we also put in a state because there are other Durhams out there in the world, Durham, North Carolina. So we've got the data. You notice here we do have some data that wasn't valid. So Benjamin kind of referred to non-valid data, but we have non-valid data here where we have something like 500 Main Street. Well, it could be North or South Main Street. We have these little slashy things right here. 500 North Duke Street / West Carver Street. What do you think would happen if you type something like that into your phone? It's not going to work. It might try to find it. It might try, but it's not going to try very well. So when we map it, we get things that look like this. Now to you, what does this look like? Just a big mess. It looks like the same thing to me. And so what I went and got all of the census block groups, all 100 census block groups that were entirely within the city of Durham, because what do you kind of notice about all of the data collected by the Durham Police Department? Why isn't there any data out here in Butner or down here at RTP? Why isn't there any data here?
RTP is special. I'm not sure.
Special? What about over here in Morrisville? No crime magically happens here? Exactly. Who's the police department here? Sheriff's office. They got a whole different data set that you can go and download that have different attributes. And so, think of the challenges of, working with just county level data. So I grouped them because I didn't want to kind of get a block group that was half in, half out of Durham County, so that you only have a part of the block group that has crimes in it, and the other part doesn't because it's managed by Durham County. So that whole idea of normalizing, meaning was it really that few crimes, or was it really that only one little section of it was in Durham City where we were only counting? So I said, I don't want to deal with that. Or William said, I don't want to deal with that. So we calculated the crime rates. And so we kind of got the total number of crimes within the study area, within Durham, within the study area. And basically we just mapped it. We made a map of the rate. The rate in 2019, rate in 2020. Pretty straightforward. We can see where they went up and where they went down. We've got this t-test stuff here that we'll talk about. His guess was that crime rates went down. Okay, crime rates went down between 2019 and 2020. And we actually kind of showed that. We said, we saw the rate, we averaged up the rates. The other thing that we did do is we did a little cluster mapping here. But in addition, we looked at qualitative analysis. And so with 2019, you can see even though there was less crimes and lower crime rates in 2019 versus 2020, in 2020, we see simple assault, aggravated assault, larceny, vandalism, where that we'll see tow abandoned vehicles. And so he saw more of the kind of more person-on-person crimes kind of going up. Maybe you were sick of being with the same people and it manifested themselves in crimes or whatever here. So this is another really good example of the quantitative analysis that we have here. And here we just did some cluster analysis, meaning, hey, let's look at the hot spots and cold spots of crime in 2019. Let's look at the hot spots and cold spots of crime in 2020. And let's look at if they changed or how they changed. And to be honest with you, they didn't really change all that much. And then we did a little qualitative or categorical analysis where we saw how they changed. So we have some conclusions. Whenever you finish something up, we always have a discussion, meaning hey, we've got some bad data here. What are all the things that you could have messed up or done wrong or whatever here? So I don't want to go too much into these here. But when we do cluster analysis, I use the word neighbor. What's neighbor mean? What's a different definition of a neighbor? Or what's the definition of near? High values near other high values. What's near mean? Getting into the weeds. We've got about 7 or 8 different definitions of near. Is your near like just someone that borders you within 10 miles? It impacts you further, as you go away. There's a lot of definitions of the word near. We'll talk about those in the second half of class, but the main thing that we did was we worked with that normalized data, and then from there, we got 2019, we got 2020. Let's subtract. Let's calculate the rates. Let's see how they're different. And look at these. And this was William here who did this. So it's 5:54 now. We'll come back here at 6:05, and what we're going to do is open up case study number 2. So make sure you have case study number 2 that looks like this. This is part of our position paper here. So you might see the title position, but we're going to be looking at this right here. And all we're going to do is just calculate the difference in COVID rates between 2 different dates. That's all we're going to do. And so I already normalized it because that's what we did last week. We're not going to do last week's stuff this week. We're going to calculate and talk about some of the challenges and some of the things that we need to think about. Do we need to normalize this stuff if there are already rates and all that other good stuff? So we'll take about 10 minutes here. We'll take a quick break, and we'll come back and keep working on these here as well. And so we got this thing up there. And make sure you fit those and all that other good stuff or extract. So extract the juice ready to go.
Yeah, it's
Town of Cary?
I think for a while.
Yeah, for working for an MPO, you got a lot of different skills that you're doing. You're not going to just be doing the same thing all the time.
Yeah.
And if you want, you can still go to grad school, not even.
Yeah, that's just a plan, which I wanted to talk to you more about that. Yeah, that was part of the question. It's like you think you could do.
Yeah. I did it, and I had a kid too. So you don't have any kids floating around, do you?
No.
No. So you're one step ahead of me. I worked full time, did it. Again, had two kids, and worked for Board of Elections and finished up his PhD stuff. So I always kind of tell people at our meeting, just make it a priority. Make it up 1 or 2, 3 things, and you'll be fine. It's about you kind of know how everything works here. So like if you took field mapping last summer, basically, did you take it as a grad class or undergrad? Grad, you already got that knocked out. So I think you'd be.
The end of the semester, I'll have 3 grad classes.
So we've had a student get out in a calendar year. We started in 2020, finished in 2021, and just went on autopilot, just everything on autopilot. Just knocked out the cores. Like this is a core. You can lithosphere right now, or
I'm not. I've heard about that class though.
Yeah, but it's being offered right now. But if it's not offered while you're here, we're not going to make you sit around and take it. So we'll have a substitute.
Yeah.
If it's not offered, we have something called water and mineral resources. That would be an equivalent to it. Atmosphere. I don't even know what's being offered. I'm teaching data science next semester. That's all I know. We're going to do like a little bit of programming and database stuff, and everything else. So, and that'll start at 5. That'll start at 5, but it's going to be a brand new data science class. We're going to do language called BASIC, and then we're going to get into Python and modeling, model builder, and everything. So you want to do that. All right. So, all right. Oh, 608, 606. Okay. So what we're looking at here, and hopefully everyone has this up and ready to go here. What you're looking at on the screen here is a map of North Carolina, and we're going to do some real kind of simple change detection analysis. We're going to map the change between a couple of dates, and we'll kind of let you all pick those out. And then we're going to open up the homework, but we have to develop the data a little more like we did last week. Because you notice like a lot of these homeworks, like week 1 and week 2 are kind of related, and then week 3 and week 4 are kind of related, build on the same thing. So the skills are definitely going to overlap. So what you looked at last week with the heart disease, deaths, rates is going to be the same exact thing that we've got today. We're going to be doing change detection analysis where we're going to have to go and do these each individually for a year. Now, we're only going to do it over 2 or 3 years with the cancer deaths or whatever, and so it'll be fairly easy to do. But when we open this up, okay, in the left, we've got our table of contents right here. Make sure you unzip it here, because a lot of times when I go to downloads or wherever you stick it here, I see a file here. This is the zip file, and then this is the unzipped file. So those of you just joining along here, if I were to click on this case study 2 here, up the top it says extract all. That means this is a zip file, meaning that I don't want to make you download all 100 files attached to this. So I just kind of compressed them all into one and put them there. Okay? Because I know a lot of times people these days, you click a button, app installs. And so if I want to provide these files for you, it gets a little different here in terms of adding projects or whatever. One of the other things that I did do here, if I add a data layer, and maybe we can look at this later here, but when we add data right here, if you go to my organization, I put a lot of like the class projects. My content, I put a lot of the class projects in here. So you'll see things like 5130 exercise 8, 5130 exercise 7, 5130 exercise 6. So those have a lot of those things there. The one challenge about those is that if you mess those up, then guess what? Benjamin's data is going to be messed up too, and Zania's data is going to be messed up too, and Jayla's is going to be messed up too. Why? Because you're all pulling from the same data source. And so there's some good things about this cloud data. There's some bad things about this cloud data. And so I typically just provide these zip files so we can open them up in our more powerful GIS software. Up in the top, we got the tabs. We got the inserts. We don't worry about this. The analysis, we're not even going to worry about. The views, we're not going to worry about. We're kind of sitting here at this very first tab with the map, and most of the things that we can do right here are within the confines of the map right here. I've got major cities, so these red dots I can turn on and turn off. And then I've got North Carolina counties that I've provided just as a reference map. And then I've got COVID rate 05/13/2021. So what do you think the 05/13/2021 means? COVID rates of May 13th, 2021. So I've got these down, pretty straightforward. You can see where they're high, where they're low. What we're going to do later is that we are going to go and look at hot spots and cold spots and all this other good stuff from there. But if you really want to know where I got this from, I went to the COVID-19 dashboard for North Carolina, and I went and downloaded it here, and then you can see that it's archived. Data behind the dashboards, and I went and literally downloaded this as a CSV file and just joined it. We've talked about the join before, right? Join, I have downloads all the zip codes. I just match them up with the zip codes and from here. So I can look at these and just download these for the different rates, which I did throughout the year. So if I right mouse click on zip code data, I'm going to open up something here called the context menu. I can open the attribute table. Now, when we open up this attribute table, what do we have going on? I've got something called ACS Top Pop. Anyone have any idea what these things mean? ACS Top Pop. X Top Pop. Anyone taking GIS 3435 remember what ACS stands for? Okay. Stands for American Community Survey. It's just a survey that's taken during non-decennial census years. So this data was taken from like 2018 or 2019 or 2021 instead of 2020. Top pop, what do you think that means? Total population, exactly. So ACS total population. There's going to be some imputation in here. I got a big fancy word for such, late on a Wednesday. What's imputation mean? I haven't heard that term before. Imputation. When we go and calculate these data, do you think there's exactly 191 people who live in this zip code? Think someone went out and counted them all? Probably not. Okay, because hey, if someone calls you up and say, how many people live in your house? Do you think everyone's going to give the right answer? Probably not. So this is the best guess here. But I also have some things here. Average number of vehicles. COVID rate 01/24/2021. COVID rate 02/22. February 2nd, 2021. 03/17/2021. COVID rate 04. So what do you think these represent? COVID rates throughout time. So I've got some COVID rates collected throughout time. Okay, I've got some other things here. Distance to the nearest supermarket. That opens up a lot of things here. How did I measure distance? Because that 10 minutes, that's what I care about. Median age, median household income. Is it metropolitan, micropolitan, or rural? Percent absentee valid, percent minority, population density, poverty rate times 2. So this is the number of people who live below the poverty line. This is the number of people or percentage of people who live below twice the poverty line. So if the poverty line is $20,000, this is the percentage of people who live under $40,000. And ACS data collects all that. This is pretty useful information. This is the number of registered Democrats, registered Republicans. I forget. There's some of this stuff, voting stuff or whatever. I'm not sure which this is because you can see that up to more than 100. So I forget what these are here. But what I want to do is I just want to calculate USDA food desert. But what I want to do is calculate the change in COVID rates between, well, what do we want to calculate? About the very left column between January 1st, 2021, and then when I first started collecting these. And when I first start collecting these here. July 6th. What do we want to do here? If we want, we could just calculate these two left columns here. When did COVID rates really go up? Let's calculate it in the month between January and February 2021. Can you do this in Excel? Can you tell me in words what you would do? I would just subtract them, right? This column minus this column, right? Did COVID rates go up? In this case, they can't because they're going to be cumulative. So once I get COVID, it builds upon the other. So if you happen to notice, look at some of these, you would notice that the ones for the month before are either going to be equal to or more than the previous month. And so I'm just going to calculate between January and February 2021. So you can see 835 versus 706, 802 versus 710, 643 versus 540. 0 versus null, zeros and nulls. I've got some nulls in here. Why? Because I don't want to go through and check all 700 of these across all these attributes. So if there's no data there, I didn't go in and put in a 0 because this is what real life data looks like. That's what it looks like. Other thing is, these are COVID rates. And so if I kind of wanted to peek at this thing a little bit, where I got the data from, are these going to need to be normalized? And if I would just happen to kind of look at the dates right here, or look at these metrics right here. These are the number of counts, rates, percent positives, all these other things, total cases. Just by looking at some of this data right here, and this is where I got the data from, zip codes, and then I went and downloaded these here. Do I have to normalize these data? 802.3. Well, these are the cases per 10,000 residents. If I subtract one from the other, if one is higher, does that mean it's got higher population or anything? Why not, Jayla? It's already calculated here. So we don't have to worry about normalization, percent difference, all that other stuff. Stuff that we're going to look at next. Well, we will, just like we did last week. And all we're going to do, exercise number 3, is do what we did last week, but calculate 2 columns and subtract them from each other. Remember what we did last week? We just ran a normalization. We just kind of summarized and we joined, and then we, calculated the rate. Now we got to calculate the rate or percent change or whatever we need to do here. So now we have to do this because I have something like 20x minus 10x. What's 20x minus 10x equal to? I don't think we're getting algebra today, did you? 20x minus 10x is what? 10x? 10x squared? 10x, yes. Where that x is the units here, these units are the same. So like Jayla said, we keep the units. We don't have to normalize, do anything special or whatever. Okay? So we've got this here. And so what we're going to do is we're just going to make a brand new column and just calculate it. COVID rate of 0120, COVID rate of 02, 22, 2021 minus COVID rate of 01, 24, 20, whatever that column is there, between January and February 2021. Because I used to collect these things every so often. So I want to add a new column. Because you can see I can just highlight this thing here. Look what I got. I got this highlighted and I'm at. highlight this zip code. We've got it highlighted on the map right here. So you can see these zip codes right here. I don't even know what these numbers are. Okay, zip code is 27844, whatever. So I'm going to clear this thing out. I'm kind of pretty much just working with map here. I'm not doing any analysis. We're going to save that stuff a little bit for next week with some descriptive spatial statistics as well. So I've got the three little dots right here, and then this is going to be my field context menu. To me, field context is like right mouse clicking. When in doubt, right mouse click, new stuff's going to pop up so that you find the answers. And so here, I'm going to go to Fields View. I've got this fields view, and you notice, look at all the fields that I didn't check, So I've got Democrats, spending on fast food, all these things, and these are some of the tricks that I've started to do lately. And so you see everything that says visible is what you see, everything that's not visible is what you don't see. So like unaffiliated percentages, high scale, white, zip, num, all these other things you don't see. Why don't I even check so much stuff? I'm trying to be sneaky, sandbag everyone here. Why did I uncheck all this stuff? Not relevant. I didn't want you to look at 150 columns there. Let's look at the 20 columns, which is more than enough as it is. So we'll go all the way to the bottom. I'm just going to follow the direction. It says, click here to add a new field. Okay, cool. I'm going to click here to add a new field. What am I going to call it? I'm going to call it rate change. I'll say January, February 2021, and I'll put a little star exclamation point. No, it doesn't let me put exclamation points. Why not? So put in anything that you want, but you can't put in special characters like stars and dots and all that other stuff because those are reserved characters, just like you would like a file name. You can't save like Tim's stuff with a little X. Maybe you can with an X, not with an exclamation point. So I just call it rate change January, February to 2021. This will be the alias as well. Next big question here. What data type are we talking about here? Is this going to be a long, a short, a float, a double, a date, a text? We know it's not going to be a date. We know it's not going to be a text or a blob, grid, or raster. So which one is it going to be? Did we have decimals on those numbers before? We did. Do you want to keep those decimals or do you want to get rid of them? Do you want to keep those decimals? If they got decimals, let's keep them. We don't need to round up or down. Okay, so we're going to store these either float or double. Me, I'm a big double person. Why? Because if we just get really big numbers, but floats and doubles are largely the same thing. If I really wanted to, over in numeric, you can click on like different number formats, meaning like, hey, I want to only store it with 1 decimal point or 2 decimal points, or I want to pad these things with zeros. So if you really wanted to, you can click on the numeric right there, and you can highlight how it's shown, because if you stick this onto a legend, so over in numeric right here, if you wanted to, you can click on numeric, and you can display it as what? A percentage or a currency or a rate or a fraction or scientific notation or angle or whatever. Me, I'm just going to display it as numeric where it's got 2 decimal places. I align it to the left. I could pad it with zeros. I could show the positive. It's always going to be positive in this case because we're going to go up. They're not going to kind of go down. And click OK. And then when I'm done, I'm just going to click Save. Right up at the top. See that button right there? Save to the right. Yeah, right up at the top. So click little Save button. And what happened? I go over to my attribute table. And I got a brand new column here called Rate Change January, February 2021. All of them are null. What does null mean? Nothing. Why are all these things null? I haven't gone through the trouble of calculating. We calculate these? Have we calculated these before? We did this last week, right? How about I give you all a minute to go through and calculate those? Give everyone a minute to go through and calculate. The little mini, just find that. Minus something. What's that there, Benjamin? Why your hand posting stuff? Why your hand? Oh, okay. But we're not doing any divide by yet.
We're just doing different right now?
Yep, because they're already rates. They're already per 10,000 people, so we don't need. We're gonna do percentages next, so.
Okay.
Yeah.
Just to make sure it's new minus old.
Yeah, new minus old. Okay, so those of you joining us online here, everyone in here looks like they got it. So we're going to go down, right mouse click on the field that we want to calculate. We're going to go to calculate field. So now it's just going to be new minus old. Like Jayla said before, we don't need to calculate rates or anything like that. Why? Because they're already rates. Okay, they're already rates there. So I'm going to do COVID rate 02/22/2021. Double click on that. You'll notice that these little exclamation points are going to show up. I didn't put those in there. They showed up because when it runs this expression in our scripting language, which I think is Python or Python 3, it knows, hey, Python, we're dealing with fields here, so don't go look for some variable called that. Click the minus button. This is what we did last week, where we calculated something times 10,000 divided by population or something like that, right? I think so. Now we're going to do the same thing. I'm going to click OK. It's going to yell at me. It says something about nulls. Why? Because I think I had some nulls right here. Okay, I have a null. Okay, that's life. Okay, because I didn't go through and... So now I've got these values. I can sort descending. I can see that there's one that went up 361. And so you can see this one over in this county here. What county is this? Wilson County? Nash County went up 361. So I can see the highest and the lowest. If I wanted to, I could right mouse click and click on statistics, and now look what we got here. Does this ring a bell? What is this? Now, what are we mapping right here? Chain. Oh, no, I dropped it. That's okay. Oh, I broke it. Now, what are we looking at here? A histogram of the change between between January and February 2021. Now, one thing that we see over here in the left is we got about 40 of these zero values. And if you were to go and kind of look at these zero values, you would notice there's a number of zip codes like around Fort Bragg that have like literally zero population. So what do you think the COVID rate is going to be in a zip code of zero population? It's zero. Well, now, what happens if you calculate the rate of something has a population of zero? What's going to happen if you calculate the rate if something is a population of zero? We got one answer going to get zero. How do we calculate the rate? Cases divided by population. We'll divide by zero. Yeah, exactly. You're going to get some bad stuff with the computer. This ArcGIS Pro isn't going to be as mean to you as previous versions of ArcGIS. So we can kind of disregard these. But does this ring a bell right here? Does this shape look like something to us? Yeah. It looks like a nice normal distribution where we can calculate z-scores and all that other good stuff. So these things are going to build upon each other. And so we've got the mean is 103.6, the median's 104.1. We've got the standard deviation. You can see this thing's probably a little bit more spread out, especially for this 361 right here. But we got a nice, pretty standard, a standard deviation or a normal distribution of these rates. Who wants to map these? I do. So that's all that counts. But so if I want to map these, I can right mouse click. Now, instead of opening up my attribute table, I'm going to go down to a quick and dirty and click on symbology. So I'm going to go down to symbology. And what am I going to do? I already have this over on the right here. Okay, hey Kai, you got a question? What's up?
Yeah, so when I calculated the field, I don't know if I did something wrong, but mine doesn't have the same numbers as yours. It has like all the nulls, and one of them is like 0. So I followed what you did, but it just came out different.
Did you calculate the different fields? Did you calculate different fields?
Yeah.
Or did you? Right, and the other thing I'm going to ask is, if you had one of these selected over here or two of these selected, it might only count. If you have this calculated and you calculate the difference, it's only going to do it for these 3. So make sure before you do it again, click that clear button so that it knows that it's going to calculate all 763 instead of just the 2 or 3 that you highlighted here.
Okay.
All right, give that one a shot.
All right, thank you.
So once again, we're already said here, we've got graduated colors. What field do we want to map? Go down. Let's go calculate rate change, which we went through the trouble of calculating. Then we can click on a color scheme. Let's click on any colors that we want here. Who likes these colors? Anyone like these? Why don't you like these, Jayla? I don't like them, Why? Because I like color ramps. I love color ramps because high, darker, higher, lighter, lower, whatever we want here. Here, I've got a kind of a white to dark right here. But in 2020, do you see distinct spatial patterns of COVID rate change between January and February 2021? You bet. Look. We got this swath right along Route 95 right here. Does anyone see this swath right here, right along Route 95? We have increase in COVID rates. And one of the things that started to happen during this time, you still have your hand raised, Kaya, or? Maybe not. Okay.
Sorry, I took it down. It
Okay.
worked though. I think what happened is what you told me.
Okay.
It works now though.
Okay, good. Oh, that's good. So what we see here is, what do we see? Our Sampson counties down there, which had high COVID rates at the beginning of the pandemic, really kind of backed off right here. But then right along Route 95, which I think was probably people were starting to drive and all that other stuff. So this is neat. Yep.
I think you should play around with the method too, because
Yep.
we're working standard. It's almost a curve, right?
Yeah. Now we got method. Benjamin brought up a good point. When we click on method, I'm a big quantile guy. Does anyone know why I'm a quantile guy?
It's the even amount.
Exactly. Each color appears the same number of times. Okay. But if we got normally distributed data, we can start to look at things like we've got natural breaks, equal interval. So I click on equal interval. Why don't I like this map here? Oh, look at this. This is equal interval. These are things we talked about right in kind of chapter 1, chapter 2, but what do we see? 0 to 72, 72 to 144, 144 to 216. Each of these ranges. What's the word range mean again? Range. No one's making eye contact. Difference between high and low. The range for each of these classes is the same. You got that 361 that skews things way far up. So most of your data, we're not really looking at a 5-class map. We're really looking at a 2-class map with a couple of other really high rollers and low rollers thrown in there. That's all we're looking at. But probably not equal interval, even for normalized data, because most data is going to be situated about the mean. So we got equal interval I don't like. Natural breaks, like the computer kind of picks out. But Benjamin brought up a really good idea where we would click on standard deviation. So now, what do you think standard deviation means here? What are we mapping? What do you think negative 0.05 to 0.5 standard deviations is? This is your z-score here. Here's our z-score. Now I can map what I got here. So everything now in purple is low versus high. So now you can see this kind of green swath running right kind of through here. Anything in green is 2.5 standard deviations above the mean. Now, what percentage of data is 2.5 standard deviations above the mean? Yeah, low percentage, probably like 3 or 5% or something like that, depending upon the kurtosis and heteroscedasticity of the data. But those are other things that we're not going to talk about in this class. We'll never talk about that. I hope not. Those are big words that I want to say. So now we can see these values. So now we can map the z-scores. We got other things like geometric intervals, which we can look at or whatever. Geometric defined based on a geometric series. Consistent with manual intervals you can pick, defined intervals or whatever. I'm just a big quantile person, to be honest with you, just because I like seeing the same color appear the same number of times. But I bet you there are studies out there that talk explicitly about what's the best method for the different type of data. And you want to do like a master's or you want to do a PhD, you're into psychology and cognition and kind of some of those things with perception, you're really blending the social sciences and the hard sciences with the GIS that people do here. And Chris McGinn and I, we went to grad school together over at UNCG, and one of the professors kind of got into that. What's the best type of map out there? What's a good map, look like? And so this is, there's research right for these things that are way out of my skill set. Those of you who are good at the art side of things, the visual design, I think would be really good cartographers and map creators. And you need to build the data a little bit, but making these visual products is still as important as ever for things like this. So we can make a map and export it and all these other things, even though it might show up on our phone a little bit different or whatever.
It's like what you're trying to do with it too, what you're trying to represent.
Yes, yeah, and and whatever you want to do, that's fine. And if we really wanted to here, I think we got data. What do we got? Map, insert, all these other things here. we can screenshot some of these things or whatever. Typically, we export these if we make an actual map, insert the layout and all that other good stuff. But I don't think we ask too much about that. This is just a case study that we're looking at. And so, half an hour ago, I'm sitting downloading data off the COVID-19 dashboard, and now I'm looking at COVID patterns between January and February 2021. This is just a real simple example of change detection. What do we do? Add a column, subtract 2 columns from each other. Don't need to worry about normalizing, because the thing we're going to do next is we're going to do a little bit of normalization. And when we open up that exercise 3B, and if you want, we can spend the next hour and a half. No, we'll probably work the next half hour here working on exercise 3B. We'll do it together, making some sense out of those maps. You all set there? Oh, I see Alondra's map. She just wanted to use different colors. All right, so exercise 3B. And this will be due next week with everything. So when we open up exercise 3B, this is what we're looking at here. Does this ring a bell? Yes. I've got coronary heart disease deaths for 2012, 2013. I got cancer deaths for 2015, 2016, and 2017 that I've exported out from a table. Ooh. And so this is part of exercise 3A and 3B. And so when I go to downloads, you can see it's sitting right here. We talked about exercise 3A last week. And so now we're kind of going to look at 3B, where we did normalization and change detection, because I sometimes think they're one and the same, where that you need normalized data in order to do change detection. So we got exercise 3, and so I've got exercise 3 with the Word document. So normalizing data. We remember we did this join, and then we did that. Remember we did those death rates, and we calculated the death rates and said, hey, all the older counties have higher death rates. And what did most of you say? That makes sense. Old people. That's the age of people who tend to die at higher rates than the other. So the next thing we've got here. And this is pretty neat. We're going to look at different year cohorts right here. And we can do whatever we want here. But we're going to talk a little bit about the small number problem. I've got a video that I posted on there that I need to talk about that a little bit. But the idea of small number problem we'll look at when we finish up. This exercise is going to be largely hands-on. Not a whole lot of questions to answer here, but what I'm looking at here, you can look at the videos. So I'm looking at number 8. Using the techniques learned in class, create a map that shows the change in deaths between 2 separate years between zip codes. The change, percent change, and this is what we're going to do in this class right here. Percent change. Percent change. All we need is a summarized and spatial join. Did we do these last week? We did. And so what I did was I went to the vital statistics database, and you can look at coronary heart disease deaths for 2012 versus 2013, or 2015 versus 2016. Now, should I calculate change in death rates between 2012 and cancer deaths between 2017? Not really, because there's not consistency here. So what I have here, what I want to map is I want to map the change in cancer between 2 different years. Let me say 2016 and 2017. How's that sound? And so I got this from that big vital statistics database sitting out there. And I just want to look at the new stuff a little bit more than working with the older stuff that we did last week. And so once again, this is what we did last week. I right mouse click. It doesn't say open attribute table. Why doesn't it say open attribute table, first of all? It just says open. It doesn't say open attribute table because it's a standalone table. So remember, this is a table that I downloaded from the vital statistics database. I exported out all the cancer deaths and I brought it in, or I did something else. And so I did a little magic before I even kind of worked with this. So when you all kind of start working with these data, you got to kind of, that's going to be your job someday instead of mine. Okay, so when I open this up, what do I have here? I've got 20,182 cancer deaths. I have like birth county, death year, race, age units, fillers, cause of death, and then all the way to the right, I've got the zip code, new sex. I assume that means that was their sex or gender in this case here. And so, and this is the age at which the people died here. So, and I can do lots of neat things here. I can calculate my statistics and all this other good stuff. So we can look at a kind of normal distribution graph of the age at which people die here. And so you can do, 70 versus 71 for the median. And so what some of our students have done in the past was we got all these and then they exported out African-American females. And what do you think it did to this histogram? Boom. Moved it all the way to the left. And so when we look at things like disproportionate health outcomes, okay, I know our PhD program has something called health disparities. You can use this table sitting right here, and I'm just looking at the median age to export out race equals 2, make this same graph and look at the difference between these and superimpose these and see stark and distinct differences between those to figure out why. So we got the cancer death rates. So what I want to do is I want to calculate percent change. Now, Benjamin kind of jumped the gun a little bit because now if I have, I'll kind of put it over here first of all. So I have, and I went and calculated for a particular zip code for 2016, it had 27 deaths. For 2017, it had 30 deaths. And let me point this to you all right here. And so what we're looking at here is for 2016, I've got 27 deaths. For 2017, I've got 17 deaths for a particular zip code. How do I calculate the percent change? I'm going to figure out it went up what? I know it increased by 3, but what's the percent change? Because if another one went from 3 deaths, 6 deaths, they both went up 3, but which one went up the higher percentage? First one and the second one. Second one. So if I just map the raw change, it's not doing much. Why? Because, well, this one went up a lot more than this one. So what's that rate? What's that formula that we have? So, O divided by O. Multiply the whole thing by 100. So just doing the math right here, 6 minus 3 divided by 3 equals 100. 100%. So if something goes up 100%, what does it do? Doubles. If you increase something by 100%, you increased your income by 100%. Is that a good thing or a bad thing? Real good. That means you doubled your income. Okay? This one right here. 30 minus 27 divided by 27. So 30 minus 27 is what? 3 divided by 27 is what? 0.1111. 11.1%. Still went up. It's not a good thing. Could there be negatives? Could we have negatives here? Yeah. Okay. What are some odd cases? If the 2016 and the 2017 have the same amount of deaths, what's going to be the increase? 0. What happens if 2016 for a zip code happened to have 0 deaths? What would be the increase? If 2016 happened to have 0 deaths, what would be the percent increase? Close. We got whatever we calculate divided by 0. What's that?
That's an error.
Error. You're going to have nasty stuff because you go from 0 to 5. You can't calculate the percentage. So you're going to run into some weird stuff here. So just be prepared for ArcGIS Pro to not be nice, and maybe we could circumvent some of those things because Kaya thought of some neat things like, hey, maybe she kind of stumbled upon these accidentally. We're like, hey, if I clicked on these 2 zip codes, it only calculated for these 2 zip codes. So maybe we might need to run a query first that says, hey, if 2016 zip code is equal to 0, let me not calculate it. Or 2016 is greater than 0. Now, the first thing we got to do is, how do I calculate the number of deaths by zip code? It's kind of the big elephant in the room. Oh my God, we did this last week, but we had a memorial, not Memorial Day, Labor Day weekend, so maybe we went and had some fun here. So, all right, so what do I have here? All the way over on the right, I've got a zip code stored as a text. How can I count the number of times each zip code appears? How do I calculate the number of times each zip code appears? I heard someone whispering it. Summarize. Yes, don't ask, tell me. So we can summarize it. Okay. So I can right mouse click. What do we do here? Summarize. Okay, I'm going to summarize. All it does is just count the number of times each zip code appears. So it'll tell me 27253 might appear 27 times. For cancer deaths, the output table, well, you know what I'm going to do? I'm going to call this summary 2016. Okay. The fields, just for the heck of it, if I wanted to, I might go down to age in years. And while we're here, why don't we average up the age in years? Because maybe age in years goes up. And you notice it had a little red star before. And when you look at some of these dialogues, what does a little red star mean? We fill out a form. You want to buy something from Amazon. What's that little red star mean? You're required. You better fill out this little thing here. You're not getting your 5-pound bag of gummy bears. That's what it means. You didn't put in the zip code. So you saw that little red star saying, hey, I need to calculate a field while we're doing this. So you can put in anything if you want. It's like the graduation forms. You know how you had to fill out the graduation forms and someone said, well, my major isn't here because we changed majors. And I just click on something so it works. Click on something so you can submit your graduation form. So what do we got here? Let's click OK. And I know I'm being a little verbose with these, but I'm giving people a chance to kind of catch up here. And so what do we have here under Summary 2016? What do I got? Let's see what I have here. I can sort descending. So I got 28655 with 127. 28645 with 119. 27406 with 117. What does this mean? What's this mean to you?
That's how many times.
Exactly. How many times people die? Who wants to do this for 2017? Let's do the same thing for 2017. Okay, I'll let you all do it yourself.
I had did not go right.
Yeah.
The zip codes didn't come through right. I'm not sure what to go.
Let's see. Because some of these zip codes don't be like code number state or garbage or whatever. You notice, yeah, 1,763. So it's finished now. It's Pulling garbage from other places. Say some of these might be O, and these might have been not pulled in by listed like another state. But we can clear those out beforehand. Okay, let's do it for 2017. Do the same thing we did for 2017. Because I'm going to ask some big questions next. Now, we're going to do this for cancer deaths for 2017. Same thing. We can put you all back at me right here. We're going to do a summarize. I'm just going to call this summary 2017. You notice a little star right there. It's like, hey, you need to put something here. So I'll just, put age in years in case I want to use this later. And the mean, I'll calculate this. We got the 28655 with the 132. Okay. How do we put all these together? What are we going to do? Who's got ideas? Now, how am I going to add this stuff to... And there's a couple ways we can do this. Tabular join right here. Now, the first thing I'm going to do, under zip codes, definitely, what's the whole goal of this? If we go back to the directions, what are we going to do? We're going to map percent change, right? Okay, so we're going to map percent change. So we're going to go down here, and we're going to map percent change. Can you add a field called percent change? Hope so, because we just did it before, right? With COVID. So let's add a field called percent change. So we're going to go to Fields View. Call it percent change, 2016, 2017. And I'll call it a double. Remember what you need to do before this. Save. Now I've got a brand new field sitting right here to the right where it's percent change 2016, 2017. I want to calculate from fields sitting in their tables. And so like Benjamin said, what do we need to do? We need to run a tabular join. Based on what? I just want to add that field that said 28655,127. I want to stick it right here and stick the other one right here. So now I can just calculate these nicely and neatly. How do I do that? Tabular join. Why? Because I've got a key here called zip code. Here you got something here called zip code, right? So now we're going to add a tabular join. Now you notice I've got 1,252 here. I got 1,282 here. While this one only has 82. So guess what? I went and calculated the number of deaths for a whole bunch of zip codes that aren't even going to be part of this. So now under my zip codes and study area, I'm going to run a tabular join where, what am I going to do? I'm just going to append the table with this. Joins and relates. I'm going to add a join. So I'm going to join what? Zip code with the what? The summary of 2016? Using what? The thing called zip code. Watch what's going to happen. And some magic is going to happen right here. Boom. Uh-oh. Anyone get it?
Of the open table. Nothing type is incompatible.
All right, hold on. Oh no, I know why. Okay, let's see. Let's try this again. Text 10. I'm going to run it again using the same exact thing, and it's not going to work, and then I'll start to worry. Okay. Zip codes and study area. Summary of 2016. Oh, wow. I'm just trying something real quick on my own here. I might click on that indexed values this time. Oh my gosh. Okay, joins and relates. Add join. Zip codes. Zip code. With the summary from 2016. Let's keep that. The code.
Format thing. The code format not the same as the. I had this problem one time.
What the heck did I just do? Let me try it with this zip here.
That's something.
Yeah.
So the summary tables, the zip code is a long numeric,
Yeah.
and the other one it's
Oh, It's a text. Okay. All right. Yeah, that makes sense. I kind of went and ignored it at first. All right. What things we run into? Zip code. When we look at the summary table, it's left justified. What's that mean? It treats it as a number. How do I magically turn this thing into a number?
In the fields do not change.
I could format it. Let's try formatting it here. Because we got another way that I can do it too. Okay, so zip code. The problem when we tried running the spatial join, we jumped. One was treating it as a number, one was treating it as a text. So a couple different ways we could do it. We can turn the old things into text, but when I click on long, basically the problem we ran into is that this is treating it as a number. You know, ArcGIS Pro wants to treat it as a number. It said the other stuff was a text. So it's comparing text to numbers. Text and numbers are two different things. Now, what if I try clicking on this thing? Why doesn't it let me change it? Because it's already created. It's already locked. What do you think I can do? Why don't I make a new field it's going to be called zip text. What do you think the data type's going to be? Text. And then we'll give it a width of 10. So now when we look at our summary for 2016, can you calculate a new field based on the existing text that you force it to be a text? You bet. So I can right mouse click, calculate field, calculate as the zip code. What do we have here? You notice the difference between this field and this field. What's the difference between them? Justification. Left justified versus right justified. Whenever you see anything that right's justified, it treats it as a text. Now, whose fault is it? Who am I going to blame? Because I can't blame myself for any of this. That wouldn't be normal. And so what I did was I just calculated this text as a field, as a text field, calculated the number as a text field. We lost it. I know. Right mouse. Yeah. Thumbs it. All right, good. Messed something up. All right. And so what we basically did here was we did something called typecasting. And you notice how it got rid of some of the zeros before. You had like really short things, really short numbers, because it just got rid of the zeros. I could have taken care of that before. Many of you who kind of set up data, the one problem with bringing stuff into Excel is that Excel wants to see stuff as a number. It treats it as a number. It sees stuff as a number. It treats it as a number. So what we're going to do here, do the same exact thing now, and we'll do the same thing for 2017. And then I'll kind of go through this. We'll do the same thing here. So I'll just call this zip text 2017, just in case I need it. And I'll make this a text just for the heck of it. I'll give it a length of 10. And I'll do the same exact thing. So I'll calculate the field, zip code. Okay, so now I've got my left justified text for 2016 in my summary. I got my left justified text for my 2017. Now I can match them up. I kind of just assumed that I had made them text to begin with, so I kind of messed that one up there. Now I'll go back here, open my attribute table. Now I'll run my join. So I'm going to right mouse click. What I got here, I'm going to keep this over here. So I'm going to right mouse click. Joins and relates, add join. I'm going to join my zip with what? My summary 2016. With what? The thing I went through the trouble of calculating. So zip text. So I'm going to join zip with zip text. Why? Because they're both text. Look what happens right here. What did I just do? Look what I got here. Now I've got something here called the frequency for this text. This zip 27209. I've got a 12. What do you think this 12 means? What do you think this 11 means? What do you think this 78 means? The number of people who died when? In 2016. We got to kind of keep track of these things here. What do you want to do again? Let's run another join. Let's join it again. I'm getting join crazy here. Now I'm going to join the zip with the summary for 2017. We're recording this so we can go back to this later. What we got sitting right here. I got a frequency of 12, frequency of 11, frequency of 11, frequency of 12, frequency of 2, frequency of 2, 3, 7, 15, 16, 24, 9, 78, 89. You get what I'm looking at, right? What can we do with these? Can you calculate the percent difference now? Now it's a text going and everything. We already have Jones there. Summary. What's it text? See, that's it. Well, that's all right. At least you know. The same thing I do. Make sure you got those. Oh, it's okay. It's fine. Joins and relates. All we're going to do is this field. Zip. Summary 2016. Oh. I'll do the same thing. 17. 2016. Ready to calculate that percentage? Right. Last thing we'll talk about here is now, remember your Aunt Sally. I was kind of busting on Jayla here a little bit. Is that, remember what we need to do first. We're going to need to do new minus old divided by old, divide that whole thing by 100. Now we got to keep track of, remember when you started doing these drop downs and joins, you started seeing little dots right there. Those dots mean like, hey, I'm already joined to another table. So what we want to do is we want to do this frequency minus this frequency divided by this frequency and then multiply the whole thing by 100. If you wanted to, you could not multiply the whole thing by 100. Why do I multiply it by 100 though? I like numbers between 0 and 100. I don't want to look at 0.732. That's me. That's my personal thing here. All right, so now I got my percent change. So I'm going to right mouse click, calculate geometry. All right. Oh, not geometry, I'm sorry. Calculate field. Now, this is where it gets tricky. This is where you make your big bucks as a GIS professional. And Jayla's going to start making her big bucks early because you know what she did? She went through and hand calculated a couple of the terms and said it's not coming out to what I did on my calculator. And so we needed to put those parentheses in. So what are we going to do here? We're going to do 100 times what? Let's put some parentheses. New minus old. Okay, let's go down here to, all right, summary 2017. What field represents the total number of deaths within a county? Frequency, good. Minus 2016 frequency. And I divide it all by the 2016 frequency. So this is it right here. This is the formula right here. So 100 times new minus old, calculate it, and then divide it by the old, right? Now, I don't want to point out Jayla, but what happens if you don't put in the parentheses? Is it still going to run? Yeah, it'll run. It's just going to do the frequency divided by 2016 frequency divided by summary 2016 frequency, which is 1, and then just do the summary minus 1, basically. So just remember your order of operations, okay? So your order of operations, what type of number should we get? Is like 11,000 going to be a good number? No, we're probably looking at like -50 to +50% or something like that. Oh, I get yucky stuff up here, but I think it still runs. But let me see my percent change here. %300. Ugh. 200%. Look what I got. Now look at these. When we look at these 300 and 200%, really what's happening? We went from 1 to 3. Is that really a big difference? This is what we run into called the small number problem. Have you heard that term before? We have like differences with small numbers, like small changes in small numbers make big percentages. That's the best way I'm going to explain it at 7:18. What we got here? And if we really wanted to, look what we can do. We can right mouse click on my statistics. Look what I got there. Let me move this thing up even. Look what we got there. Now we got a nice normal distribution. It really skews it when we go from 1 to 3 or whatever it was, 2 to 8 or whatever. You know, it might have just been a really bad year or whatever, but you don't want to go from 80 to 240. That's the problem. You know, but I can live with this is the right word, but I go from 1 to 3, that's a 200% increase. And so there's ways that you can kind of vet out those numbers or whatever. And the North Carolina Department for Health Statistics does a good job of that. And now I'm ready to make some maps. Mouse click, symbology. This will be the very last thing we'll do, and then we'll let you kind of finish up the homework. So we'll be at a good stopping point right here. Here we are. Me, I'm going to stick with my quantiles right here. So now what we're looking at here is cancer death rate. So now we can start to see over in the southeast part right here. Not mapping POP 2010. What am I mapping? I'm going down and mapping. Change. Present sheet. So now you can actually see the area in Wilson County, south of Fort Bragg, Lumberton. Those are the areas, as opposed to over the eastern part, they don't have high rates of cancer between 2016 and 2017. Over in the western part, they do. Now we got an age grade and do all that other stuff that we're talking about, but real simple example of this. I don't want to use the word simple, but when we do change detection, these are the things we look at. I think I ask in the exercise, we run into like 200%, 300%. When we look at these numbers right here, people are going to get really like disturbed by that. So what are some ways that we can maybe tease those out? Do you think of ways that maybe we can say, hey, I don't want to go from 1 to 3. How can I accumulate more data? Maybe I'll let you think about those for the homework as well. How do you get more data to do change detection analysis? You need to just look at 2016 versus 2017? Why don't we look at 2010 to 2015 versus 2015 to 2020? Instead of looking at 1 to 3, we might go from 15 to 17 now, and it will kind of tease out all those other data. So that's about it for me today here. We've got some of the maps to finish up. Those of you kind of working, click the save button. Save it onto your flash drive, zip it up, send it to yourself, come back, all that other good stuff here. We're, 90% of the way done here. Okay? 90% of the way done. And so for the actual exam, we're not going to do any of this. Okay? We're not going to do any of this, but I wanted to highlight a couple examples where you are going to calculate pop change between 2010 and 2013. But you're not going to go through and do all the tables and all this other stuff. I'm starting to give all of you, especially some of our PhD students who are doing work in health disparities or people who want to do work in health disparities, some of the idea of working with raw data and then kind of brushing up on some of the summarized and spatial join skills that we have. And so I posted a reading. That won't be due for 2 weeks. But I also posted an Esri exercise on time series analysis because we didn't do any neat things where we're doing like visualizations and things, maps changing, and I'm not really good at that. So I just assigned a tutorial so you could get really good at that. So I provided that as well. So that's about it for me here. Tomorrow I'll post a summary of everything we did, and then we should be good to go. And make sure you get yourself to a good stopping point, and we should be set. All right, we'll see you all later. I'm going to just click stop here, and I'll be with you here in a second, Jalen. Stop.